the mic. I hope it's working now. So I fumbled, I must confess, I fumbled around a little bit with my OBS settings because I wanted to have a file which is showing both audio files in one there. So if you can hear me now, that would be great. If you, otherwise I can just simply watch my own stream, right? Let's see if that works. Sorry about that. I was talking all about the symmetry constraints, and it seems to have gone lost. Okay, I can hear myself now, but I think, yeah, you can have a point. Definitely, there's a point. Yeah, it was not transmitting. Oh my god. Stupid OBS. Stupid OBS. Perfect. All right. Thanks for letting me know. I would just have continued like that, and everything would be gone to shit. All right. All right. So let's go back. I was just explaining a little bit about what you can find in the help about symmetry constraints, right? So you have symmetry constraints for your optimization, and you define this with a base point and a vector. So, and the problem is now that you have, in case of plane symmetry, you would have an easy way because you have one side of the plane and the other side of the plane. So you have one repetition, right? But with cyclic symmetry, the number of repetitions is to be defined. So, and how this works, I was just reading about it, as I never dived into that deep into this topic. It explains you here a little bit about how the symmetry is achieved, and it uses harmonic indices, and you can also choose those. And I really don't know if I ever did that, but and I'm not quite sure if I know exactly what is meant by that. But as far as I understand that, you could have symmetry in multiple ways, right? So if you have the segments from 1 to n, you could have multiple ways, but let's say that one segment must be the same as another segment. For example, now let's just use this, and let's just use here a cross, right? So segment 1 would look like, not like segment 2, because segment 2 would be empty, but segment 3 would be exactly like segment 1. So, and those are the harmonic indices, I think. So every second segment is the same for this cross, but you could also imagine that you have a star which has a line through each segment, and that the harmonic indices would be, in this case, every segment. So every segment is the same. You see that you can have how you would call that, sub-symmetries, right? So that means you have a pattern of repetition, and this pattern can be almost basically arbitrary. And then it tells you that if you choose a lower number of those symmetry, I think it's segments, right? Lower harmonics lead to highest contribution, right? So if you have if you have every segment, that would be a low number because it's 1, right? But on the other hand, I don't think I got that really. But you can see that, for example, if you just specify 5, right? Yeah, 5 repetitions. So this would have an effect of having 5 sections which are more or less the same. Let me see. As far as I understand that, lower numbers have bigger contributions. That means if you have an arbitrary large number, the structure can be very different. So it can be, there's a high magnitude of possible solutions. But on the other hand, no, I'm not really thinking that I got that. I have to think more about it. All right, let's read further. Analysis type: linear static analysis with cyclic symmetry loading. It is recommended to use all the solution harmonics to obtain same result as the full model. Removing some harmonics could lead to loss accuracy. For large models, Removing higher harmonics could help with reducing in the CPU time. Yeah. Wait a second. I think I have if I think about it a little bit, it could be that it is not really talking about symmetry constraint, but those would work in the same way. But because to just analyze a structure, you could also pick a segment like arbitrary, and then just do a simulation basically based on this. So I'm not really sure what I'm looking at. So if you have that a linear static analysis with cyclic symmetry loading, you can do that. But here it says cyclic symmetric loading. It is recommended to use all the solution harmonics to obtain the same result as the full model. So you're talking about reduced model. In this case, this is not really the symmetry constraint we are now facing with the optimization. It's kind of the same thing, but yeah, it's not really what we should be looking at. Let's go back and see. It's all talking about cyclic symmetry analysis. Maybe I have to search for something different. I mean, it's definitely known under a different word named pattern grouping. So, but pattern grouping now would also have the plane symmetry in it. Yeah, and I think now I see that it's a little bit more tedious to find. And that's maybe why I get these questions a little bit often about cyclic symmetry and how to apply it. And this is exactly also the reason why I would want to make this video. And yeah, this is more or less, yeah, okay. Draw directions. And there should be the pattern grouping somewhere here. 6 extrusion constraint. Yeah, we have here pattern repetition. Plane symmetry, yeah, okay. Cyclic symmetry, I think this is more like it. All right, now cyclic symmetry can also be defined through the use of pattern grouping. Okay, like I said, you have a base node, a first node, or in this naming scheme, they call that anchor node, and this defines you a plane where it is acting in the normal direction of the plane. All right, so you have that, and now the number of repetitions is the second thing which you have to provide. And to add planar symmetry within each wedge, a second reference to grid needs to be done. So you could also have a planar symmetry additionally to the cyclic symmetry. So this could be done as well. But for our case, this is not really a thing because we would not have a third dimension here, really, because in our model, you see, that's just shell. So planar symmetry would not change anything, really. Yeah, okay. So let's go back to the model. First of all, we have a shell optimization now here, right? And the shell optimization consists of a design space and a non-design space. You have the red elements, which are non-design space. You have some boundary conditions, and you have the symmetry condition, right? So this is what we have done until now. Now, I would want to do a little post-processing here and to just see different models, because what we have run here is some of the data. I think what the only thing what was missing was the one with free symmetry. Let me see. So just to show you here, this is the folder where I have stored the models, and you see from 1, 2, 3 is missing, 4, 5, 6, 7, 8, 9. So those are the simulations, the optimization models I run until now. And now I would want to run the third one as well to just be complete here. So let's check back on our pattern grouping should be here, right? So you have here pattern grouping. Where am I? Design variables, then here in the topology design variable, and then in the property editor under pattern grouping. And you see here that's one plane symmetry, which is completely bonkers. But we will change that to be cyclic. Now here the number of the cyclic repetitions, in this case 3, because that's the one we are missing. And then anchor point selection. Let's choose to use your coordinates because I think the center is exactly here. So I think that should be fine. Let's make sure to just create no panels for me. Oh, I'm sorry, no panels. And by the way, in order that you can see that better, I move myself up here. Hope that's a little bit better. All right, now with geometry and points, you could just create a point and then enter the coordinates. And that should be exactly the center, which it is. Almost. Almost. So you would be maybe wondering, why the hell is this not really in the center? So we don't really care much, but why is this not in the center? Because the mesh is not regular. If the mesh would be regular and you have angular wise, you would have the same node pattern all around the circle, then you would expect to have the center point here to be exactly at the center, right? But in this case, you have it not, because you had, or I had used calculate the master node here, and so it was a little bit off. So we could fix that, I think. So my quick fix would go to F11 and just do the replace point. Not sure how to do it with the panels, to be fair. If I just know do something like replace replace element. No, it's not really that. Let's see if I'm even right to do it like that. So I would choose this point to replace. I cannot select it anyhow. And okay, forget about it. So you would want to update this element. All right, come on, let's do it. First of all, what I have here is not a node, it's a point. So this is the first thing I think could go wrong. And the second thing is how to do it. Forget about the points here. You would want to go edit out and then choose the element selector with pressing the button E and then selecting the element. Then go to model and to RBE3, I think. This should be RBE3. And now you see you have already selected your independent nodes. Those are the other nodes, the slave nodes. And this is the dependent node. One is selected. Let's select this one. You see? It's not working. It's not working. And yeah, and if I have now my forces gone, I will throw away the model and I'll just leave it be. Yeah, I have lost a moment. Yeah, this is something which happens if you choose to change the node, the forces which are defined at the node, they are gone. So don't do it. Okay, screw that. I will just go away and throw this model away. Just load in the model with 1 times the rotation. So I will just use it here. And if that's not perfectly in the center, that's okay for me. Now, I want to change the design variable. So I go into the design variable browser, go back here, and then just use this one. Yeah. So as of here, this is perfectly fine anyway, because you would choose coordinates and not the node itself. So if you would have selected the node, it would be slightly off. But with the grid, it doesn't really matter, to be honest. So the thing is now here selected. We have 3 times u_cyc, number of cyclic repetitions for cyclic symmetry. This field defines the number of radial wedges for cyclical symmetry. The angle of edge wedges is computed as 360 degrees times, not times, divided by the number of cycles. Yeah, default is blank and should be an integer above 0. Okay, that's done. Now let's just quickly run that. Is that correct though? I will just simply make sure that it is. So I think the path should be the one. Yeah. And now we just want to change it to with a 3 at the end, so that we can track that. And this should give us no warning with renaming, but should just run it. Okay. Now this is done. The thing is now, what should we do next? Now comes the post-processing part. So let's assume we would want to post-process it. And just that you know what we are dealing with in terms of how the old ways worked with Hyperworks. Or you could still do it like that, but I'm not sure how much versions you would have left to get to the new layout. So you could launch Hyperview. This is basically Hyperview. And this is the old layout, and yeah, so you would just load in a bunch of simulations. For example, we'll just go to the correct folder, and load in the design variables, right? So this is the density plot, or this will be the density plot. You can plot that, and it's with one cyclic symmetry. So this should be any structure really, because you have one symmetry per 360 degree. So this is actually not much different of a non-cyclic symmetry. But yeah, let's see if we find any asymmetries here. Because I think with the free symmetry we found some. First of all, let's ditch that away. Yeah, there are asymmetries here. You see that this wedge here, that corresponds to that, but that looks kind of different, and this looks kind of different too. So this corresponds to that one. Yeah, keep in mind that we have a asymmetric loading. We have a moment in the center which is applied, and all things considered can be seen as a center load. But on the other hand, we would have a bending force at one of the poles. I'm not sure which one, to be honest, but we can look that up. So if we just go and rotate it like this, so that direction is here, and I think it was, no, I think the forces are not shown, right? Let's see. Yeah, okay. All right, it is this one. So top Y, top Z direction. That means it will be, in other words, top Y, top Z direction, this one. Yeah. Could we have spotted that? I think you can see that it has higher density elements here. So yeah, I think, yeah. So if you would have to guess, I think you would come up also with that. Because here you have more compliance, so it will have more of a reason to put elements there to reduce it. And so this is what happens. That's exactly what happens. Now, we want to combine or to look at different simulations. And the thing how to do this here is to choose a layout. And the layout is chosen here. It's a little bit different. Now, if you want to have 9 separate windows, right? So we could work like this. So it could work like this, and now just choose to change the result, because yeah, that goes a little bit quicker. The model is the same anyway. So this would be the second one, this would be the third one, so this will be a little bit boring to watch me do this, but it will load the results in every window, and now then we can compare And we have to reload the third one because the optimization is still ongoing, so it's not really finished. So 1, 2, 3, 4, 5. I think for that, it's better to get myself a little bit down here. So 6 would be here. And you also see this this light blue line here. This indicates which of the windows is active for opening it. Yeah, so that you're not confused what is in which window this will load in the results once you click apply. And don't worry if you just apply it, it will ask you, do you really want to? Yeah, no, I want to have it here. So this is how to do it. Now here comes a trick. That's pretty cool and amazing. And by the way, the optimization for the third one has finished. So I will just reload this one and see also it remembers. So you can just say apply once more, and you have the model. So now comes the trick. First of all, you can maximize and minimize a window like that, and you can just choose to change something. For example, what I always try to do is with the legend, I really don't see any point of having a legend in a scientific format. So we go to have a fixed one, and the number of positions is 2. That is pretty much enough, and you don't have too much clutter. Then you would have a note, because in your reporting you would want to have to know in the screenshot which one is which, unless you want to edit that in something like Inspire or Inspire. What I'm telling you, InDesign? No, how's it called? Yeah, in some sort of vector graphic program like Inkscape or so. And then you can do your notes there. But if you wanted to have it here, you can, and just you go into the notes menu, which is here, and add a new note and just say this is with model with one with, let's use USIM colon 1. So you could just add this, and sorry, that was too much. Okay. Again, model with USIM colon 1. Now apply, and now you have it here, and you could just place it here, and you could change the color and the font and whatever. Maybe we will want to make it a little bit bigger. And why I'm doing there's a reason why I'm doing that now compared to later. You will see in a minute. So you see, I think this is readable, and you can also see the shape. So this should be all right, right? So I think. Then we could go a little bit further. Should we really have just a contour plot, or should we have also the isoplot? Isoplot means that you would have just a structure. I mean, that makes sense to me, especially to have it in the background, because to have the background will be white. So you would have a cleaner picture. On the other side, there's a point to be made about the design space as well. I will leave it like that for the moment. And then also for the contour plot, you would have to change or choose between, if you want to have an average method, just look at the difference. This is unaveraged. You see that every element has its own color. And you could also shade the corners between to see the elements even a little bit more. But if you want to print it, and you would have to have it a little less from scale, so tinier, that would lead to not being so nice. So go with the shaded elements better. And now watch that change to simple. So simple averaging means, yeah, you have finer contours, but also nonsense like the snake line and stuff like that. But yeah. There's points for each. I will go with the simple here just because it looks a little bit nicer to my eyes. And now I have done all this, and I don't want to do this all at the same time at all the different things here, right? So you can just quickly, and now bear with me. This is really a cool trick. Right click here. Then you go to apply style, current page all selected. This command does the following. It changes all of the other windows. Or is it pages? I'm not sure. I think it's Windows. All the other windows to exactly the same formatting style as the ones you have selected. So, boom, that's it, right? And now let's look at those beauties, right? For sure, what you would have to do is to change every node here because it cannot increment. So you would want to change that to 2, that to 3, and stuff like that. So we'll do that quickly. And maybe we will also write the compliance it achieved, because that's more or less the score, right? So the score you get for your optimization job, or this was the goal, to be more precise, the objective. The optimizer had the task of minimizing the compliance, and yeah, that's exactly what measuring criteria you should look at in terms of comparing different solutions. So this is it. Well, let's be a little bit more clear about that, because there's a little bit of confusion going around this topic. So you have a minimization of compliance as a solver task, right? So this is your task. The one thing to look at is how good did the solver did his job, right? Did it achieve a very low compliance or did it not? And you can compare that because you have the same bounding conditions and the same design volume at the beginning. And then the other side of things is that you look at the design constraint, right? So right now we would have a given fixed volume constraint. What do I mean by that is when you look back at the optimization, this optimization was set up like this, that you had a optimization constraint of volume frag, and that should be upper bound 0.05. If we change that to have it, I don't know, to be 10% or so, the structures will look different. And in fact, I think that's quite a good thing to just see. Maybe we will run that. Yeah. Now I think I will do that in a second, and then the other thing what we want to do is yeah, we would want to extract all the compliance values, because that's more or less, if we want to pick a top winner, we would want to pick yeah, we want to see how much of a difference the different symmetry constraints made, right? And also the questions of which number of symmetry should we take, right? So you could look at here, and I think the guys from the manufacturing team, they will go nuts on those kind of structures. I mean, you can always see that there are some, yeah, you still need a little bit of human intelligence to see and interpret the structures still. But yeah, we didn't do a routine which always finds the best solution. So it was not a task to do that, but just look at the structures like this one. You see it here. Maybe the simple is doing it no good. If we just change that back to none, gets a little bit clearer, but on the other hand, it really doesn't. You see that there's no combination of those two. Does that make sense? I mean, you would apply a torque and you would apply a bending force here. So this structure here is completely meaningless if there's no connection in between here, right? Yeah, so going back, if you would have to do a little bit better job of looking at the output files, you would just create, just because you're interested, you would open the notepad and see. Let me quickly close the other files. Now you would choose to go into the out file and just scroll down and see what was the end message. Optimization has converged, feasible design, all constraints satisfied. That is the first good thing. You would want to see something like this, because that tells you that it did not running up in a limit of too many iterations or stuff like that, which is arbitrary, but still. It did also not fail to converge the optimization, which is also a good thing. The second thing you would want to check is to check here the density. What strikes me here a little bit is that you don't have very high density elements. And that is in that model, this is an indicator that the volume thread constraint is too harsh. Because even if it wanted to make a line connection which can fulfill the goal of not letting that structure yield to eternity, of just one element line and connecting line the loadings to the boundary conditions, I think even then it would have to use more than 5% material. So it could not do that. So it had to choose lower density elements. But you as an optimization guy, you would want to have a 1 and 0 design. So you penalize the medium density elements. And so that is not really helping. So in this case, my first observation here would be that probably the constraint for the minimized volume, the constraint for the volume track is too low. In that case, we will just increase that. Now, how to do this? I will just choose to use a little bit of different tools. I mean, there's multiple ways of doing it. The first and easiest way is to just go back to our optimization model, change that to change the volume frac here to 0.1, the upper bound, and then run it again. Yeah, and always changing the symmetry and running all again. So this could be a thing. But I don't know, really. There should be a better solution. And this is always a thing of which I would recommend to you. Always search for a better solution than doing it the first way which comes to your mind. Because then, I don't know how to tell you or how to describe that, but you will not evolve. So the second thought which came to my mind was to use HyperStudy. You could use HyperStudy and read in the text files and then just set up the simulation, and the simulation would just change the numbers in the text files and then run the simulations all by themselves, by itself. That could be another thing, but I think it's for this easy task, it's too much of a hassle to set it up. Third thing which comes to my mind is to just copy every .fem file into another folder and change it by using a text editor. And I think this is exactly what I will be doing. Now I just want to walk you through that. I will just create now a second folder. And this folder, I will call it just like the same, what we have used until now. And I will just call that with, let's say 10%, right? 10%. Now, I will now go here and just search for .fem files. All right, I misspelled it here, but it's okay. So I had from 1 to 9 every .fem file, and I will copy that now into the 10% folder. Now, if you have Notepad++ not installed on your system, shame on you. It is by far a better text editor than the typical Notepad. So unless, Notepad has some cool features too. I think I even saw a automatically a logger you can enable with the standard Windows Notepad. That was pretty fun. But no, Notepad++, seriously, it's a good thing. Now, we are here now in this file here, and what we want to change is something about the constraint here. See, so this line we would want to change. So I copy that line. And now I just search in files. So that's under edit, and I think it's search in files. No, it's with search in files. Control-Shift-F. And this will let you search and replace in files. So I will just paste that in here, paste it again for the second time. So I have just replaced 005 with 010, right? Now, in which folder? I would just go in here, and this is exactly the folder I'm currently in, so perfect. Now I will just go replace in files. And also I could choose to have a filter if I wanted to just having an effect on .fem files. Yeah, so this could be a thing, but in this case I just have .fem files, so there's not really a point in doing that. So I do it like this, replace it in all files, and it does not do it. What? Okay, let's go with that. Let's go with normal. All right, replace in files, 9 times it replaced it. So that's okay. I close that file. Maybe we want to do that once again for 15%, right? So we could just copy that another time and call it 15%. Oops. %, and same thing. I go in here. I go in search, replace in files or search in files. Now I would want to look for with the 10, right? And I would want to replace it with 15. And let's check the folder, if that's still the correct folder. 15%, right? That's correct. I'm in normal mode. I will go and replace all 9 times. All right, has done that. Now I can run the simulations, and how to do this with a batch thing here. You could just simply go in the folder, copy the path to the folder, and then you just launch the OptiStruct launcher. I think this is called different now. I have to tell myself that every time. It's called Compute Console. It's not called OptiStruct anymore. Yeah, Compute Console. And now you could go to the folder. You can post links in here. You just select all of the files and press open. You could now have run options, for example, the number of cores and stuff like that. Let's see the number of threads. What is this machine again? Getting confused about it. It's a 24 core, 12 cores, but 24 processors. Yeah, let's go with 12. Oh no. No. Let's go with 4. And that's because I want to have it run multiple times. Is that even a thing here? No, that's not. Okay, forget about it. No options. Just run it. And now it will run all the simulations in sequence, right? And after that, or not, no, I can do it in parallel because why not? Sorry. Compute console. Because I could run 2 simulations at the same time. I think the memory requirement on this is not really that big. 800 megabytes, yeah, that's not really much of a deal. So I can run a second one. Even faster would be to just run everything in parallel. But I would have to set that up. In the meantime, what we can do now is we can now check on sorry, lost for words. The compliance values, right? Compliance values, yeah, because we had all this, but we have no idea about the compliance values. And now you could go in every text file and you can extract the value of the last iteration, or you use a tool for that. And I have done a little script, so like this one. I showed that in the last live stream or so, but I will show it a little bit again. So how to use it at least. So there is this task CLI, and then you have a objectives command. But with task, you would have to need double dashes, and then you can give in the arguments. That's a task thing. So it's not really programmed that way, but because you could give arguments for task, and you can also pipe command line interface arguments into the subline command in task. So it's a little bit complicated, but just use dash dash and then a space, and then you can choose to use the commands here. Objectives. And now we would need a path. And I have just copied that path here because I don't really know if you would want to have dashes. I'm not sure. We will see about that. But the thing is, you would have to want double backslashes and no single backslashes, because it will not work, because task has a problem with that. Yeah, it's a little bit annoying, but yeah. Okay, see? This is so beautiful. Sorry, I'm really I like that. So you see, I just pasted in the folder, and it went through every out file and chose to output the compliance value of the last iteration. And now you see, let's look at it for a little bit. The first one won by a lot. Then the third one, no, actually not. The third one is also pretty good. Yeah, so the first and the third, those two, they have won in terms of minimizing the compliance. And because the design space is the same for everything, and optimization constraints are the same, you can directly compare those values, right? That means, looking back at it, so choosing no symmetry at all, that means 1, right? This is the way to win. Or using 3. And then what's the next best one? 2? Yeah. Then 2. Then 4. No, not 4, but 6, I think. Yeah, 6 is also pretty good. And then it's pretty much gone. 9 is also good. You see, the multiples of 3 are good examples of getting a low compliance score. That sounds wrong, right? So compliance here is not something to do with your work philosophy and stuff like that, or your work environment, but it's rather how much the structure will yield under stress. Yeah, it's not really that either. No, it's how much it will deform under load. That's more appropriate. Yeah, so having a low compliance in that case is a good thing, because that's what we were aiming for. And having a low compliance is the same thing as saying have a high stiffness. So in the model, if the model is very stiff, that means it has a low compliance, because those are inversely proportional. Yeah, or they're related, to be honest. They're related. Okay, now we can just copy those values and put it into the notes to have a little bit more of a complete post-processing picture. And then I want to try and see how to save the session file here and open that in a new version and see how it comes and turns out. Because that's a new thing. You can use post-processing in Hyperworks too, right? So the new layout. And that's basically more or less it, because that's what I'm aiming for. Now, so much to do. All right, in the meantime, the simulations are running. The first one is already completed, but it will take some time. Okay, now I will just go with that and change the node. And let's see, I have a second line with compliance. 0.05. Let's see how this turns out. Yeah, I don't like it very much, but I don't want to change it either. So yeah, I will just leave it like that. I will go with 2 decimal places of a precision. So second one. Yeah, would you have guessed that this is the stiffest one? So obviously the first one and the third one is pretty much the same thing. And it looks stiff compared to the others. Yeah, so I think there's a point to be made about that these two results are the winners. And the fact that you have free loading points, or free load application points, to be fair, and having a symmetry of 3, yeah. And that a non-constrained model performs better than a constrained one, that's also clear, right? So to pick that as the winner was clear. But yeah, what do you think about the comments? Can just put it into the comments and we can have a discussion about it while I'm inputting all the values here. So the second one was 0.16. Just thinking about the unit of compliance. I've completely forgotten about it. But I know it was something like the inverse of the stiffness. And stiffness is force by millimeter, right? So it would be millimeter by force. But on the other hand, I remember that you calculated by multiplying force and times displacement, so it should be Newton millimeters. Yeah, I think it's Newton millimeters, but we can look that up in a minute. So the third one, no, the fourth one was 0.34. I mean, look at that, right? You have, I don't know, 6 times the compliance. 16 times the detail. No, that was a bad joke about a video game. Okay. 5.4. Oh, let's see. Maybe we we get to the 16 time. So the 6th one has 2.0. Oh, fuck. Mm -mm -mm. 7.7. And finally 2.8. So, what do you think? 7.7. It's not quite 16 time. Well, it is. It's by 4 more. No, it's not. I cannot calculate very good in my head right now, to be honest. But 5 times what equals 77? 15, 16. Yeah, could be 16, man. 15 times 5 is 75. Yeah, it's not quite 16 times the detail. Yeah, the jokes are getting worse. Yeah, so this is talking a little bit more about it. So what we have accomplished here is we have done a multitude of simulations pretty quickly, and we gotten the result out of the out files with a script pretty fast. And then we just arranged it a little bit nicer on the post-processing, and now we want to save that here, right? And to save it, you can just hit File, Save As, Session, and there's so much confusion about... Let me just quickly save that. About the session files. No, let's call that density plot. Yeah, there's so much confusion about... sometimes I get mails and with questions, and all they send me to look at is those files with the session, right? So this one. So this. MVW file. This is session files. And if you just open that with a notepad, this contains in clear text only links and how to arrange it and what colors to plot and stuff like that. So it's just having basic preferences and your paths. You see, cyclic symmetry 9. So this is a relative path in the folder which the session file is in. So actually that should work in the same, in the other directories as well. Let's see if that does, but I think so. And yeah, you have just settings and how your contour plot is done and the transparency is set to off and whatever. You see, this is not the actual result data. The actual result data is saved in binary form in the H3D files. So if you open that with text editor, good luck. You can forget about that. And I think in the res files as well, if there are any. Is it no? I'm mixing now. I'm mixing now different solvers. You have des files, sh files. In the sh files, there should be results as well. Yeah, you can see, for example, here. I think those are density values. Yeah, I'm not sure about it, but you have results in multiple files, but not in MVW files. The MVW files, they don't show you any results. So if you have a question or want to ask something, don't send just a session file. But the good thing about the session file is we don't need a model here, so we can just go to new. We can open that now in the new Hyperworks. Let's see. I'm very much looking forward to see what this gets us. Huh? There's no Hyperview session file. Hypermesh Hyperworks session file. I don't know. I should be able to open that. Open. Is there session? No, there's not. Okay. But I can also just save it as a model. I'm getting a little bit confused. Let's see if the drag and drop works, because if not, I would have to change this all to the new layout as well. Because I know it's possible. I know it's possible. Because you have a window layout here as well. So you can choose to have something like this and then load in different kind of things. Let's see. What can go wrong? Boom, works. Man, it's not that pretty because the thing is, I think with the sidebar, yeah, but you can get to the results pretty fast. But how did we do that? Actually, now I'm a little bit confused. So I'm now in Hyperview. It changed it to Hyperview. But because I was having the problem of not being able to go back to Hyperworks. So it changed it somehow to Hyperview. But I missed the button where to do that manually. So definitely we're on the results. Sorry about the optimizations being started in the background. And we now have all different plots, like contour plot, and you see that's all the Hyperview layout and stuff. But how was it changed? This is the synchronize button, also very important. Now let's see. Can I save it now as a session? Save as session. Yeah, this changed. So as I was just importing the MVW file, it changed. But on the other hand, you see still there is something different about the window. So the first one here has this cube. So I think this is the main instance, right? Or is it? No, it's not the main instance. It's just the active window. But let's say you want to have one of those windows maximized. Is there a way? So you can go to this, but which one is it now? Let's say I want to work something here. Can I now change to one window and have that structure? No. Okay. Ah, this is where it changed the type to Hypermesh Hyperview. Yeah, okay. So this is, okay. Now, what about, what is this? Not getting that, to be honest. Let's go back to the 9 times view. Yeah, I think we can drag that, change type, and enlarge it. Maximize. Yeah, okay. So I see it now. You see the 3 buttons, which are kind of transparent at each of those windows here. You can maximize this one, work here, and go back with minimize. Yeah, that's cool. And right now, there's no synchronization between the windows, but you could enable them to be synchronized. And so this enables you to quickly look at the model and just arrange it a little bit here. Yeah. Yeah, all right, that works. Oh, okay. Always learning, always learning. So we got to see how this works and how to change the different applications. So this is done at the top right. Okay. And if you change it to Hyperview, for sure you will have to load in different session files. Okay, that's good, thanks. You have nodes here, you have trays, all the different... That's the thing with learning, right? So you're comfortable with what you have learned and what you can apply. Now a new thing comes along. As always the thing. And the first thing you will feel is frustration, because there's this way of you know how to do things, and there's some sort of calmness to it because you can relate. You can just see that and just think to yourself, all right, I know what to click to get my desired result. Whenever there's something new, first thing is a little bit of frustration because you don't know what to do. And then you have to just pierce through this frustration and learn a new way, and then it's all calm again. But the other way of possibility you could go is to just quit it. You get frustrated and say, all right, I'm never ever opening Hyperworks again. Where's my old layout? And stuff like that. And I mean, I try that it's obvious that I try to just go through that phase of frustration and just learn how to do it differently. So this moment right here. So I clicked on the nodes, and what I was expecting is to have the familiar nodes panel here. So with that one. And instead, I get this mini tool up here, which is kind of hard. So I would now want to select a node or a component or an element or nodes. So they combined multiple of the functionalities in one tool, I think. And now I can create a node, hopefully. No, I could select a node. Okay. That's not really good. Okay, nodes. Can I click here? Yeah, so I've created a node here. I can drag it around. Can I size it? No. But this was not possible in the old one. So I have a label for the node. I have a text for the node. For the text, there comes a different pop-up menu where I can just type in stuff. This is some text. All right, and there's now a placeholder for different variables. Or let's say I want to have the model title here. Can I just drag that, double click? Insert field. Okay. Okay. Somehow it did not check the model. Yeah, because there's no model. It's just a Hyperview file which I loaded in here. Okay, I want to edit that. Now comes a different menu. Why? But you see, I can now let's see if I have a different field. But you see, you have now 2 different kind of ways of seeing it, because there's now a frustration cycle inside the frustration cycle. You have a new layout and you said, all right, okay, I'm gonna learn the new layout. So you learned the new layout and thought, oh, cool, you have some fields I can put in, but double click is not working. Okay, you have to press the button insert field. All right, good. There's a note here and it has missing text. You want to open it again. And now you're getting again another layout to just do the same thing. So this is kind of the frustration into the frustration. But once, all right, how does this work? Okay, I have a plus here, and then you can do a load case title. So this gives you the fields, but now shrunken down to just that set which actually has values, maybe. Then this would be another good thing. Let's see. We go for load case title. And then, what can I do here? Entity editor. Oh my god, no. Go back. Go back. How can I make that back? Just, okay. Okay, again. I'm deleting that. I will input the load case title, and now I want to have that gone. What do I do? This one is clearly not it. So just pressing escape, maybe? No, that did not change it. Okay, another thing or another way I know how to do it is just go here and then just use it like this, right? So that should be a load case title. So insert field, okay. Yeah, this works, right? This works. But I'm still not quite sure. Enter, it's not it. Pressing another. Ah, you have to just press something out of the node. Okay. And can I delete it with just hitting delete key? No. But maybe if I just go to nodes, select that, and now delete it. Yeah, that works. So you see, it's not that bad, to be honest. So this second edit function, that's kind of strange. But on the other hand, I know maybe that this is a little bit smaller and could be handy to just, if you want to have a node edit, it will not open the whole menu all again. Could be a good thing, could be a good thing. Yeah, but so just like that, we learned a new way. Ah, still we have our selector. That's, yeah, the selector. Man, the selector is powerful. To be honest, the selector is pretty powerful. Can delete almost anything with that, and it is context sensitive. I like that about it, because if you have not any nodes in a model, it will not show you that. So I have measures here. Not sure if I did any, but okay. Yeah, so I like that. Now, how to save that as a screenshot? So it used to be just a click on a button here. And what I really liked also was this functionality that you could choose to either save that in a file or save it to clipboard immediately. And if you just press this button, it copied that to your clipboard. And don't mind the optimization thing going on here, but if I just have now PowerPoint and we'll just copy paste here, yeah, you have it as easy. So this was pretty neat. Let's see how this goes in the new design. This would be file and then screenshot or so, screen capture, image to clipboard. So you would have to make 2 clicks, and it takes you a little bit longer. I don't really like it, to be honest. If there's a shortcut, that would be even better. But yeah, I don't see that there is any until this point. Now let's see what we're getting. We just hit a new thing here. Yeah, it looks kind of different. The lighting is different. And the aspect ratio is different, but that could also be because of the sidebar. Yeah, but you can work with both, to be honest. It's not that much of a hurdle. So you could just go away with that. We have it synchronized, right? Let's choose to just slightly off-put it here. And just once more going for screen capture. Screen capture, image to clipboard. All right, and let's paste it in here. Yeah, why is this yellow? Oh my god. Oh my god. We have to change that. Okay, this is yellow because it's selected. But to be okay. Quick, don't move. All right, file, save, or screen capture. Image clipboard. Come on, there must be a screenshot. There must be a shortcut for it. Uh-huh. Shortcut. No. He. No. No. No screenshot. Or I don't know. Maybe there is, and I have not met it. I'm sure you can customize it that it has a capture shortcut, but until now I don't see any. Maybe there's also icon I missed. That could also be for report, maybe capture. Oh, I'm not sure what this does now. Ah, report. Okay, I like that. I like that. But I don't want to have a report here right now. No, cannot delete it. Doesn't matter. Yeah, you have a session file here. Yeah, that's also cool. Results file. Result model browse use, you would say. Okay, I did a screen capture. Now let's go to PowerPoint and just paste it in here. Just compare the two to each other. So it's a little bit dark here. But in terms of visibility and usability, it's quite good, I would say. Yeah. Yeah, you can use this. You can use this. All right, and I think I will use this more or less for the video I'm doing about a cyclic symmetry. So this will be definitely on there. Yeah, and I think that's about it for today. So I was just doing a little bit little bit of the work for advancing the topic, and yeah, just making a little bit of progress, I guess. Yeah. And I think I have done that. And the next steps would be to just also post-process the other values and see how the thing changes. Then again, if I just overdo it with the constraint loosening, so the design constraint loosening, if I overdo that, that means that the structures will get big. And that means that we could play around with min member. And that means a whole nother topic of symmetry, results, comparison, and stuff like that. So you see how this tool of getting the compliance values will definitely help me in achieving that much faster than if I had not done that tool. I mean, for sure, that tool cost me around, I don't know, for sure 2 to 3 hours to program. But on the other hand, I did that to do it properly, because I want to relearn or better learn to do a CLI properly. And so I just founded this, I don't know, I just made this foundation for future work to put in there much more than just this post commands, but maybe also pre-commands and stuff like that. So stay tuned about that. I think this will be a pretty interesting topic, I think, and also pretty useful if it is like that. And yeah, so if you have any questions or comments, yeah, you can just let me know. I know that the timing of the live stream is unfortunately maybe a little bit odd to do it on the weekends, and it's not that I don't have anything other to do, but yeah, I was just trying to experiment a little bit with the live stream functionality and stuff. And yeah, if you want more of those kind of contents, also with the possibility to just interact and ask questions and stuff, Yeah, tell me that, because for me it's quite high of an effort to do it besides the job, besides family and whatever. Yeah, let me know if you want more of that. Then I will try to make it work. And until then, I will just try and do what I can from time to time. And I think the Cyclic video will be out in a couple of days. Yeah. I put a little bit of effort in it to have also a little bit of a slides to show that I can summarize what we have now learned and discussed here in a couple of hours within a couple of minutes. So there goes a lot into it. And yeah, so I also just try to give a little bit of a insider inside information of how I compose those videos and stuff like that. Yeah, so yeah, thanks for watching, and yeah, see you guys later. Bye bye.